Question number 4. This question is of trigonometry. Show that the equation 3 tan square x minus 3 sin square x minus 4 is equal to 0 may be expressed in the form a cos 4x plus b cos 2x plus c is equal to 0, where a, b, c are constants to be found. We have to express this trigonometric equation in this form. The given form involved all the terms in cos x. So first we use the given important identity to make this sin square cos square x, because sin square x is equal to 1 minus cos square x, and we convert tan square into sin square over cos square x. So we will finally, after simplifying, we get the above equation in this form. So first we write here 3 tan square x 3. We can write this tan square x we write 3 sin square x over cos square x, sin square x over cos square x minus 3 sin square x. We convert this sin square x into cos square x, so we can write minus 3 into 1 minus cos square x minus 4 is equal to 0. So now we will convert this sin square into cos square x. So we can write 3 into 1 minus cos square x divided by cos square x minus 3 into 1 minus cos square x minus 4 is equal to 0. Now we can take LCM. These are the fractions 1, 2 and 3. There are 3 terms. We can take LCM, or simply we can multiply each term by cos square x to remove this cos square that lies in the denominator. So to remove this cos square, we multiply each term by cos square. So both sides. So this becomes 3 into 1 minus cos square x minus 3 cos square x into 1 minus cos square x minus 4 cos square x. Right, on the right hand side there will be 0. We have multiplied each term by cos square x. We get this. Now simplifying it, we get 3 minus 3 cos square x minus 3 cos square x minus, or this minus plus, we get 3 positive 3 cos square x uh, 3 3 cos 4x minus 4 cos square x is equal to 0. Collecting the like terms, 3 cos 4x, only term in cos 4, 3 cos 4x. Adding these cos square terms, we get minus 10 cos square x plus 3 is equal to 0. No, this is the required form. This is the required form. Now easily we can uh, sh- uh, tell that the quotient of x4 is a, but we have found the quotient of quotient of x4 quotient of cos 4x is a, but we have found the quotient of cos 4x is 3, so a is equal to 3. A is equal to 3, and quotient of cos square x is b. We have found minus 10, so b is equal to minus 10, and c is constant term, that is c, and c in the question is 3, so value of c is 3. These are the values of a, b and c. The next part of this question is part B. Hence solve the equation 3 tan square x minus 3 sin square x minus 4 is equal to 0 in the interval 0 to 180 degree. Hence mean we will use the above relation. We have to solve this equation which is given in the start of the question. We have to solve this equation. Mean actually we have to solve this equation, just we have convert it in this form 3 cos square 3 cos 4x minus 10 cos square x plus 3. So we will not solve this, but we will solve this equation, that is we just we have expressed in this form. So we will solve it by taking a suitable substitution. 3 cos 4x minus 10 cos square x plus 3 is equal to 0. We are taking a substitution. Let cos square x is equal to y. This is a substitution. Then this equation will become 3y square minus 10y plus 3 is equal to 0. Factorizing it, this equation, now we will factorize this equation. We get two values of y. Factorizing 3y square minus 9y minus y plus 3 is equal to 0. 3y common, y minus 3 minus 1 y minus 3 is equal to 0. Y minus 3 into 3y minus 1 is equal to 0. So we get two values of y is equal to 3. Putting y minus 3 is equal to 0, we get y is equal to 3. From here we get 3y minus 1 is equal to 0. We get y is equal to 1 over 3. Now re-substituting the values. This is a substitution. Cos square is equal to y. So we are putting here cos square is equal to y. Cos square x is equal to 3. But this is not applicable because when we will take square root each side, we get the value of cos x that is greater than 1. So cos x cannot take the value greater than 1, so this is not applicable. Because when we are taking, we have to find cos x, when we will take square root each side, we get the value of cos x that is greater than 1. So this is not applicable because cos x cannot take value greater than 1. So this is not applicable. Only the solution will be from this equation. Now putting again cos square in place of y. So cos square x is equal to 1 over 3. Taking square root each side, we get two values of cos x. Cos x is equal to plus minus 1 over under root 3. This means that there are two values of cos x. Cos x is equal to positive 1 over under root 3 and cos x is equal to negative 1 over under root 3. So from here first we will find the basic angle, that is x is equal to cos inverse 1 over under root 3, that is x is equal to 57.7 degree, correct to one decimal place. This is the answer. No other answer will not is not valid, because since cos x is positive, cos x is positive in the interval. By this sketch ASTC, cos is positive in the first quadrant and the fourth quadrant. The first quadrant we have found the angle 57.7 degree, but in this quadrant number 4, the angle will be 360 degree minus this basic angle. So we get the angle that exceeds the given interval. So we are not taking the angle in this quadrant. Only the answer is in this quadrant, which is 57.7 degree. Or next is we are using here cos x is equal to negative 1 over 3. Basic angle is same, but no, in this case cos, the value of cos x is negative. Negative cos x lies in the second quadrant and the third quadrant. Again, in the third answer in the third quadrant we are not accepting, because the interval is given to 0 to 180. So only the answer will be in this quadrant. So in this second quadrant, angle will be 180 minus basic angle. So we get the other answer 180 degree minus 57.7 degree. We get the other angle is 125.3 degree, correct to one decimal place. So there are two answers, 57.7 degree and 125.3 degree, correct to one decimal places.